If you've ever had to deploy AI, you know the headache of managing different model sizes for different hardware. It's a huge pain. Well, today, we're breaking down a new approach called Nemotron-Elastic that has a single, powerful promise. Deploy once and scale it anywhere. Let's dig into how on earth that actually works. This quote right here gets to the heart of a deep operational pain. I mean, if you're in MLOps, you feel this in your bones. Every single time you need a slightly smaller model for a phone or a slightly bigger one for the cloud, it's not just a tweak. Nope, it's a whole new product with all the QA, all the docs, all the on-call rotations that come with it. And that leads us straight to the core problem we're talking about today, model multiplicity. It sounds kind of formal, but really it's just the operational chaos that explodes when you're suddenly juggling a whole family of models. One for mobile, one for edge, one for the cloud. It becomes a logistical nightmare, fast. Okay, now this table, this really lays out the two different worlds we're talking about. On the left, you've got the conventional way, the pain we all know. A separate training project for every size, which means your code bases start to drift apart, you're maintaining multiple Docker containers, and the worst part, you find a bug in one, and you have to go back and retrain or redistill every single variant. But then look at the right, the promise of Nemotron-Elastic. One training run, one code base, one container. And a bug fix? You do it once and it's fixed everywhere. It's a completely different way of thinking. So let's make this really concrete. Imagine you're a systems architect for a new math tutoring app. Your product team comes to you with a list. They want a snappy, offline model for the mobile app. That's going to be your 6 billion parameter model. Then they need a low-latency 9B model that can run on edge servers and classrooms. And, of course, for the premium users hitting your cloud API, you need the big one, the full 12B model. In the old world, congratulations. You're now the proud parent of 3 completely separate MLOps projects. So what's the actual cost of that 3-model strategy? Well, if you use standard techniques like distillation to shrink your big model, you'd have to burn through about 750 billion, that's billion with a B, tokens, just to create the smaller 9B and 6B versions. That is a staggering amount of compute. But here's the thing, and this is so important, it's not just about the cost to the GPUs. The real killer, the hidden cost, is the organizational overhead. Every new model size you add linearly increases your team's complexity, your QA time, your engineering effort. It's this cost that can absolutely crush a small, lean team and stop them from building AI that can actually adapt to different places it needs to run. So Nemotron-Elastic comes in and proposes a pretty radical shift in thinking. What if model size wasn't this permanent, irreversible decision you make at training time, a decision that creates a permanent fork in your whole project? What if instead it was just a flexible choice you could make at runtime? Right, this is the question any sharp engineer should be asking right now. It sounds a bit like magic. How can a single file on disk, one set of weights, possibly act like a 12 billion, a 9 billion, and a 6 billion parameter model? It kind of breaks your brain a little. And the answer is this really clever technique called nested slicing. The key idea here is that the smaller models aren't just squished versions of the big one. No, they are complete, fully formed models that are strategically embedded to literally live inside the weight matrix of the larger model. They're not separate things. They're like these surgically extractable cores. This is my favorite way to visualize it, the Matryoshka doll analogy. It's just perfect. Think of that big 12B model as the largest doll. You load that one file. But at runtime, you can choose to crack it open and just use the fully functional 9B doll that's nested right inside. Or go one level deeper and run only the tiny core 6B doll. It's one object, one file that contains multiple complete versions of itself. So cool. And the technical secret sauce that actually makes this nesting trick possible is a new hybrid architecture. It combines the power of traditional transformers with the efficiency of these newer Mamba state space models. It's this unique design that gives the model this crazy elasticity. Okay, so we get the how, the science is cool, but let's talk about the payoff. Why does this actually matter for your infrastructure, for your budget, for your entire deployment pipeline? What's the so what?
First off, the training efficiency is just wild because they train the big model with a special loss function that also trains the smaller inner cores at the same time. Nemotron-Elastic cuts the total number of training tokens you need by a factor of 7. You're basically getting 3 production-ready models for the training cost of roughly 1. It's an incredible deal.
Second, and this is where the real RAM revolution happens for deployment, you get a 43% reduction in total memory usage. I mean, think about that. Instead of managing 3 separate Docker containers and trying to cram 3 different models into your precious VRAM, you just load one file. That's a massive, massive simplification and a huge efficiency gain.
You can almost picture it like a dynamic slider or a volume knob. You load the full 24 GB file onto your big server for full power. Then on a developer's laptop, the engine just dynamically masks off the outer layers and bam, you're running the 9-beep slice. And on a phone, it goes even further, using only the innermost 6B core for maximum efficiency.
And this right here brings us full circle, back to that initial promise. Deploy once, scale anywhere. You have one single model artifact. On your server, it's a 12B monster. On an edge device, it's a nimble 9B. And on a phone, it's an efficient little 6B that can run offline, all from the exact same file. This just completely changes the game for deployment pipelines.
Now, look, this all sounds almost too good to be true. And whenever something sounds that good, you have to ask the critical question, what's the catch? Is the performance of, say, that sliced 6B version you get from the big model, is it actually as good as a purpose-built native 8B model like Llama 3?
And here's the honest-to-goodness trade-off. A native model like Llama 3 8B that was trained from day one to be exactly that size will probably eke out slightly higher scores on some benchmarks, but it gives you zero flexibility. The sliced Nemotron model trades that tiny little bit of peak benchmark performance for a revolutionary amount of operational efficiency and simplicity. So the main thing to walk away with is this. The number one reason to get excited about Nemotron-Elastic is its game-changing flexibility. The goal here isn't to top every single leaderboard at every parameter count. The goal is to fundamentally change and simplify the whole process of building and deploying AI that can live anywhere. And that really leaves us with a final, very strategic question for every systems architect and MLOps leader out there. Is chasing that last 5% of raw benchmark performance really worth 3 times the operational complexity, 3 times the cost, and 3 times the engineering headaches? That is the fundamental choice that Nemotron-Elastic puts on the table.